Lesson 7-9, Polar Graphs of Conics. There's an alternate definition of a conic section, and it is a locus of a point in a plane that moves its distance from a fixed point, called the focus, is in a constant ratio to its distance from a fixed line, called a directrix. Now, a locus just means it's the set of all points and that this point would cover as long as it meets the requirements of the ratio between the focus and the directrix distances. That ratio is called the eccentricity. The eccentricity is less than 1, it's an ellipse. The eccentricity is 1, it's a parabola. And if the eccentricity is greater than 1, it's a hyperbola. If the eccentricity is less than 1, it's an ellipse, and you can see in polar form, the focus is at the pole. P is this distance between the focus and the directrix. So one focus is 0, 0. The conic bends around the focus and away from the directrix. There's a parabola, bends around the focus, away from the directrix, and a hyperbola. This arm bends around the focus, away from the directrix. So here are the equations of all polar graphs of conics, that at least the horizontal and vertical. We have the top, it always starts R equals, the top is always EP, and then we have 1, and then it'll be plus or minus, and then it's E, that's all the same, and then it's cosine or sine. Vertical directrix, it's cosine. Horizontal directrix is sine. Vertical directrix they're going to be x equals some number, and cosine is x. Horizontal directrix will be y equals some number, and y is sine, or sine is y. And then if the directrix is in the positive area, it's a plus. If it's in a negative area, like to the left or below, we have a minus. So identify the type of conic of r equals 2 over 2 plus cosine theta. Well, our generic formula is going to look like the one that says EP over 1 plus E cosine theta. So we have the plus and we have cosine. So first of all, we know because it's cosine, it is a vertical directrix. Because it's a plus, we know it's to the right of the pole. And now to simplify this, we need the denominator start with a 1. So we're going to multiply the top and bottom by a half. So it'll give me r equals 1 over 1 plus a half cosine theta. Thus, this half is E. That is less than 1, so that makes it an ellipse. So it's an ellipse, the vertical directrix to the right of the pole. All right, identify the type of conic and graph. All right, so again, this one looks like it's going to be in the form, we have a minus, and it's sine. The sine means it is a horizontal directrix, and because it's a minus, that means it's in the negative area, which is below the pole. I want the denominator to start with a 1, so I'm going to multiply top and bottom by a half. which means the 2 is the E. That is greater than 1. That makes it a hyperbola. All right, if we're going to graph it, let's kind of sketch out where the directrix is. So the top, that 3 over 2, is EP. Well, I know E is 2, so P must be 3 over 4. So the distance from the focus to the directrix is 3/4. All right, we're going to graph with a table. So here's this. I'm going to put my directrix in first, which is about 3/4 of a unit below the focus, because remember, a focus is right here in the center at the pole. And then we're going to make a table on the calculator and plot all the points that it gave. So I got all those points by making a table on my calculator and then connect them with lines. Find the polar equation of the parabola whose focus is the pole and directrix is a line x equals -2. All right, on my graph I put the line x equals -2, so it's a vertical line 2 units away from the origin or the pole. And that tells me right away that P is 2, because P is this distance from the focus to the directrix. Let's see, we also know it is a parabola, and for a parabola, E is 1. All right, we have a vertical directrix, and it is to the left of the pole. Vertical means it's going to be cosine. To the left means it'll be a minus. So it's R equals EP, 1 minus E cosine theta. E is 1, P is 2, E is 1. So it's 2 over 1 minus cosine theta. And there's the graph. All right, let's find the polar equation of the hyperbola with the focus at a pole and vertices 1, 3 pi over 2, and -9 pi over 2. So the first thing I would do is I would graph these points. All right, my first point there is at 3 pi over 2 and 1, so it's straight down and 1 unit down, and -9 pi over 2. Pi over 2, of course, is up, but since it's -9, we count 9 down. So that's a rough picture of the parabola. The center is halfway between those 2 points, so there's the center. Now that helps us. The center to a vertex is A. So that is 4. And the center to the focus is C. So the focus, remember, is the pole, and that looks like it's 5. The eccentricity is C over A, which would be 5 over 4. All right, remember, the conics bend away from the directrix and around the focus. Our directrix is somewhere in here. I don't know exactly where, but somewhere down there. Therefore, it is a horizontal directrix, which means it's sine, and it is below the pole, which means it's negative. So we have r equals EP 1 minus E sine theta. Well, we know that E is 5/4. Now, we probably don't like the fractions, so we're going to multiply the top and bottom by 4 to get rid of the fractions. Now that we've done that, we can pick one of the points and fill it in for r and theta, and that'll give us p. So I'm going to use this first one. So r is 1, and theta is 3 pi over 2. Well, sine of 3 pi over 2 is -1. So that makes 9. So 9 equals 5p. And that's really all the further we need to go because the numerator is 5p. So our equation is r equals 5p, but 5p was 9, over 4 minus 5 sine theta.